Today I want to show you a quick tutorial on how to create a velocity versus time graph and a position versus time graph using data from the dot diagrams we produced to measure gravity. The first thing I would suggest you do is type in your data, and this is the measurements you made between points. For me, I did it in millimeters, and I'll quickly do that. Suppose it was 14, 15, and so on, down to about 83. Notice this data is just made up, so don't interpret these graphs as being what you should have gotten. Then what I would do is for dot number, started list, you can do a couple numbers, 1, 2, 3, and then if you select those numbers and see down in the corner there's this little black box, if you click on that and drag it down, Excel will recognize the pattern of numbers you've started and start filling in the rest of them for you. That's called the fill handle, and you'll see us use it many times. It's extremely helpful. The next thing I would do is in the change in time box over here, you should type the amount of time in between each dot. For our spark timer example, that was a 60th of a second. So I'm going to type a fraction equals 1/60th and hit enter. I want you to notice that this particular box I named delta t earlier by clicking in this name box and typing in delta t, and that allows me later to refer to that particular amount of time by just typing delta t in a formula. Now, let's see if we can convert these distances, which were in millimeters, into a more convenient and standard unit of meters. To do that quickly, I'm going to create a formula, and anytime you type in a formula, you have to press equals. And to convert from millimeters to meters, I need to take this box, which I'm just clicking in, or I could have typed C2 if you'd prefer, and divide that by 1,000. Always hit enter when you're done typing in a formula, and that locks it into the computer and has it calculate it for you. Now I could repeat that step again and type the same thing in this box and in the box underneath and in the box underneath, but let's practice instead using that fill handle. If I grab the bottom corner here and drag it down, notice it automatically filled in all cells underneath with the correct formula. The next column is a running total of how much distance we've traveled so far. To enter in a running total, probably the easiest way is to start by using a formula, which is just the starting point so far, and hit enter. And from here on out, I'd like to add how much I've gotten so far, that would be this value, to what the next measurement was. So I'm going to press equals what I've gotten so far plus the next measurement. Notice it added 14 and 15 and gave me 0.29. Now I'm going to use the fill handle and bring this formula back down again. Rather than dragging, I'm just going to double click on it, and it automatically went all the way down to the bottom. For the next column, which is the velocity that the tape was moving at that specific point in time, we need to take the distance between the two dots at that spot and divide it by 1/60th of a second. So we'll do an equals. We'll take the distance between the points and divide it by 1/60th. And rather than typing 1/60th, I'm going to type in delta t. And that will refer to this cell, which is 1/60th. I prefer this option because later on I might want to play with the change in time and see, how much of an effect it might be if it was a 50th of a second or a 70th of a second for error analysis purposes. Hitting enter locks that into the computer, and I'll click on that cell and double click the fill handle again, and notice the speeds gradually increase. The last thing I'd like to do is to create a running total of how much time has elapsed, and we can do this easily enough. I'll start with just delta t and hit enter, and the next thing I'll do is how much time has elapsed so far plus another delta t, and just click on that particular cell and fill that all the way down, and you'll see that the time goes up. The next thing we need to do is to create some graphs. We'll start with the position versus time graph. To create a graph, you need to tell Excel where your X values and your Y values are that you'd like to create a graph from. The fastest way to do this would be to click on both columns, B and E, which we're creating the graph from. To highlight two columns at once, you have to click on one column and then pressing Control and holding it, click on the other column, and notice how they're both selected. Now, if we go to Insert, Scatter Plot, we'll choose this first option, which is just the dots, and notice it created a position versus time graph. Let me suggest a couple changes that we ought to make to this graph. First of all, we definitely need labels along the x-axis and the y-axis. It probably should have both horizontal and vertical lines, and I'd also like to put in a line of best fit. We could do each of these options one step at a time by pressing on the Layout tab and adding axis titles, grid lines, and a trend line. But if we go to the Design tab, one of these options in the chart layouts already has all of these things. Layout number 3 is very useful for lab reports. Notice how it changed the graph significantly. It added titles here, added vertical lines, and put in a line of best fit. The x-axis should be properly labeled as time and have the unit of seconds. The y-axis should be properly labeled as position and have the units of meters. Another change I'd like to make is that I don't think this particular graph needs a legend. There's only one thing graphed here, that's position versus time, so I'll delete the legend. The third thing is that even though I wanted a line of best fit, for this particular graph, it's actually better to have not a line, but a polynomial of best fit. And so I'm going to click on the trend line, and I'm going to delete that. Instead, I'll go now to the Layout tab and add this trend line by hand. I don't see in this list polynomial trend line anywhere, so I'm going to click on More Options. And midway down, you'll see polynomial. The highest power in this is a 2, so we'll leave it there. And a very important box to check is to display the equation on the chart so that we know what the formula was. Now I'll hit Close, and you'll see that it put in a line of best fit. And here's an equation for it. You can drag the equation around. You can change the way it looks by going to the Format tab and adding all sorts of different options. Personally, I like the axis numbers that they have here, but if you had wanted to change these, perhaps not have quite so many lines, I usually right-click and go to Format. And instead of using the automatic settings, you can fix the settings to whatever you might like. Maybe I'd like to go all the way up to 2 meters instead. And the minor unit, instead of having it be quite so small, let's have the minor unit be tenths of meters and the major unit be half meters. Now you can see there's not quite as many grid lines, nor are there quite as many labels here along the side. Looks a little cleaner perhaps? Anyway, you can create the velocity versus time graph the same way, except for selecting columns B and F. And instead of using a polynomial of best fit, you'll use the line of best fit. Looks like this graph also needs a title. We'll go to Layout and add a chart title. I think the centered title would look a little bit nicer. And maybe I'll call this Position of Falling Object versus Time. If you'd like to change the way that particular title looks under the Format tab, maybe I'll add this one. and move it just a little bit so I can still see my numbers. Once you have the graph looking the way you'd like, clicking anywhere in this chart area to have it selected, you can copy it or right-click and copy or Control-C. And then you can go to your lab report, and in the data section, if you hit right-click and paste or Control-V, you'll see that it puts the graph inside, and you can continue on with your report.